So by shifting it left to the 2 bits, we multiplied it by 4. Shifting it left 3 bits would have multiplied it by 8, and so on. So shifting right 8 bits, I can't even figure out. That's like dividing it by 256 or something, 2 to the power of 8. Yeah. Back to 1792. It got small because we divided it by 256 or whatever 2 to the power of 8 is. Oh, by the way, y'all's home machines, when you install Visual Studio, it may be complaining that your license is about up, that your trial is about to expire. What you do is you choose Help, and then one of the choices, who's got their laptop here? So under Help, Register Product. And then it'll say check for updated license. And now it should be licensed for a little longer. Okay, so my short-term memory is so bad. What is the option under Help? It said Help and then Register. So what is that? Help, Register. Yeah, okay. So it's not here because I'm not using the same version. But on your laptop or you know, your home desktop computer or whatever, you're going to choose Help, Register. And once you choose Register, it'll come up with a little dialog. And one of the options is check for updated license. And if you click that, it should update the license to at least the end of December. So one more thing about hexadecimal. I did talk about hexadecimal, so I did tell you that if we have something like this, right? We could turn those into hexadecimal values, right? By grouping them into 4. And then if we had our little lookup table, we could figure out, you know, that this was an A, and that this was an 8, and that this was a 0. We did this, right? I'm not expecting you to be able to do it off the top of your head like I am, but we did do this. Is this familiar or unfamiliar?
Yeah, we did it.
Okay, okay. And so that's a 1. And that's a 5, and so on. That's a 3. Okay, so the reason we did hexadecimal, and when I say we, I mean the universe, everybody who uses programs, is so that you could represent 4 bits in 1 digit, and 8 bits in 2 digits. So remember, 8 bits is a byte. 4 bits is a hex digit. So every byte can be 2 hex digits. Or every byte is the same as 2 hex digits. Don't know why I can't spell today. And so a byte being 8 bits long can hold a number of up to 255. 1, 2, 3, 4, 5, 6, 7, 8. And if converted into hex, that's equal to FF. Because you remember, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have some letters. That's a 10, that's an 11, that's a 12, that's a 13, that's a 14, and that's a 15.
Wait a minute. There's no number above 15?
Well, there is. Is there no number above 9? 10. 10's above 9. So what's more than an F? 1, 0. If you were going to start counting in hexadecimal, it'd look like this. Yep, there is no number higher than F. There is no digit higher than F. So when you're going to keep counting, like that. And so on. So what does this mean? If this is the 0th place, the 1's place. So this is 16 to the power of 0 in that column, and this is 16 to the power of 1 in that column. So if you have this number, 16 here. This is the same thing as 1 times 16 to the power of 1 plus 6 times 16 to the power of 0. And we said that anything to the power of 0 is what?
0.
Yeah, so this is 1 times 16 plus 6 is equal to 22. So in hexadecimal, 1/6 is equal to a decimal value of 22. If we counted it out, that's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And that's what we got. So why do we even care about hexadecimal? Well, one reason is so that we can, well, if you have text, if you type in the word bad, how is it represented in memory? Now, this isn't bad in hexadecimal. It's just bad in text, bad in typewriter keyboards. Or if you type in the word, Bobby, there are some numbers written into memory, and then if you hit the save file, it'll get saved to disk. If you read it across the internet, those numbers are sent, down the wires. But what numbers? ASCII values. ASCII is an agreed upon standard for converting typewriter characters into numbers that can be stored in memory. And then back again, right? If we go ASCIItable.com. ASCII's got 2 I's in it. ASCIItable.com. We see the agreed upon standard. People came up with this. IBM had their own standard, and then this one was invented in the 60s, and IBM ignored it as long as possible, and finally everybody standardized on it. Who speaks English? Why do I say that? Because if you look on here, there are no German characters and no Korean characters, and and stuff like that. So, but for the 60s, it was pretty cool. So you could look at what BAD would be written in. The bytes for BAD, because each byte can hold 1 letter, would have been a 66 followed by a 65 followed by a 68. And in lowercase, BAD would be a 98 followed by a 97 followed by a 100. But it's a lot nicer to use a counting system that never gets more than 2 digits, right? So instead we'd use hexadecimal. Capital BAD would be 42, 41, 44, BAD. Lowercase BAD would be 62, 61, 64. So go to another site. HEXED.IT, which stands for Hex Edit. HEXED.IT. And then do new file. Oh, I guess it comes up straight with a new file already. And so I said that if we typed in a 62, 61, 64, go ahead, put your cursor here. Type in 62, 61, 64. Whoops, 64. Back. Right, these are the bytes. The bytes in memory, and these are the typewriter text. So just for fun, click on Open File and go find one of your notes files if you keep notes. Or go find one of your CPP files. If I go to Documents,
I'm going to download my own CPP.
find Visual Studio 20, whatever, right, Projects, go in. Well, that's a CS file, it's a C# file, but it'll look similar. There's my program, right, in typewriter characters. And these are the bytes that are saved to the hard drive and loaded into RAM. So if I go and I load up one of my files, one of my text files, one of my old lectures, and you see where it says lowercase e here, I could look up to see what an uppercase E is. Now I did this recently, but so I happen to know that if a lowercase E is a 65, and uppercase E is a 45. And so if I do that, now there's a capital E rather than a lowercase e. And if I save the file, if I exported it and wrote it back to disk, then the next time I opened it, I would see that that had an uppercase letter there. I don't think I grabbed the right one or saved it to the right place, but you get the idea. Hex Editor shows you the contents of memory of a file. The typewriter version is over here, and the bytes are over here, and the way that these are hooked up together is that this stuff is encoded in ASCII. Now, ASCII's not good enough. Right, it was great for the 70s, great for the 80s. People used it up into the 90s. Perfect for saving English text. But if you look at it, not going to do very well for German, right? There's no diacritical O's and umlauts and stuff like that. Not good for Spanish. There's no, ins with the squiggles over them, the diacritical marks. It's certainly not good for Vietnamese and Korean and and kanji and Russian, and because it's got a limit of only 127 different letters, typewriter characters, because they're using 7 bits. If they used 8 bits, you get another 128, and so computer scientists in the 70s thought that it'd be fun to fill them into these things. So you could draw pictures on the screen with boxes and stuff. And so, in some of the European characters, like U's with umlauts and diacriticals and whatever are in here, but not enough, right? Not enough to support every language. So another encoding standard other than ASCII was created called Unicode. ASCII is 1 byte per character, so it can only store one of 127 different values, right? Each byte can only hold 1 typewriter character. Unicode takes 2 bytes per character, but the advantage is that with 2 bytes you can have up to 65,000 different typewriter letters, right? 65,000 different characters. And so you can have your Vietnamese and your kanji and your, and your French and your Russian and whatever, all in 1 character set. So by using 2 bytes per character rather than 1, you can support pretty much any language on the planet. And nowadays even more, like your typewriter emoji, right? You want to send it, a sad face, or, picture of a train, followed by, a knife or whatever, your favorite emoji are. All of those are Unicode characters as well. It's just that they take 2 bytes per character rather than 1. So while we're on the topic of HexEdit, just do open file and go and find something strange like a Word document or a PowerPoint or something. I'm going to open up a Word doc, a PowerPoint. And once we actually get down into it, we can't read it at all. This is the guts of it. A Word doc will look the same way. And the reason why is that the contents of the Word document are not stored in ASCII. ASCII is just plain text, like a .txt file, a notepad file, a text wrangler file, a .cpp file. All of those are text files.
.py?
Yep, you got it. Python files. So this file, up at the top of it, has a header that indicates what its file type is. When I opened a PowerPoint, the first 2 bytes were a P and a K. If we go and find a Word document, they may be something different. Let's see if I can find a Word doc. Here's one. Also starts with PK, but it's got some different numbers up here. And then if we went and we found an image, like if I downloaded an image, header.gif. Let's go back to HexEdit and open that file.
I bet there's going to be a bunch of
And see,
good stuff.
GIF 89. That's because the GIF format was invented in 1989 by the people working at CompuServe. And so these 3, 4, 5 different letters indicate, the format of the file. And then there's some other information in there as well. So that's the file header. And the file header you can inspect with a hex editor to get some information about the file. if you know a lot about the details of the file format, you may even be able to change it. Used to be a popular thing back when people played games, you know, on their home machines of a type that had a save file, and then you could load up the save file in something like this, and you could increase the strength or the hit points of your character or something like that. Or maybe you had a Game Genie on your Nintendo. What the Game Genie did is it was the same idea. You could change the value of bytes in the Nintendo's memory to give yourself infinite lives, or you know, whatever. That may be enough about bits and bytes. I want you to have the idea of hexadecimal, but I don't really care if you can convert from and to hexadecimal. I really do want you to have this idea though, just you know what a bit is and how you convert that to that, right? That's a 0, that's a 1, that's a 2, and that's a 4. So if I gave you this number and I wanted you to convert it, you would know how to do it, right? Because these are, well, let's not make it that large. Let's just do that. This is the 1's place, that's the 2's place, that's the 4's place, and that's the 8's place. So what is 0101? It's a 1, there's no 2's, and a 4. So it's a 4 plus a 1 equals a 5. How about 1101?
13.
Yeah, it's a 13 because 8 plus a 4, there's no 2's. So 8 plus 4 is 12, plus 1 is 13. All right, back to our lecture. To our PowerPoint.
I mean, that is insane.
So the last thing we talked about before we started talking about bits and bytes were stream manipulators, the I/O manipulators, where you could set the width and you can control whether that number was left justified or right and how many decimal points it had. What was the header file you had to include to get that to work? I/O manip. We had to use # include I/O manip in order to use these things. So like if we went up here and we added # include less than I/O manip greater than, then when we wanted to print a floating point number out, if we wanted to print out the value of pi to 4 decimal places, we could do that. Cout less than, set precision to 4 decimal places, set precision parentheses 4, in parentheses less than, fixed. And then now we can print out pi. Cout less than quote, pi equals, space end quote, less than, math dot, except it's not math dot pi. Oh, dadgum. You have to do some kind of special includes in order to get pi defined. Excuse me for having to Google.
Sounds like a PMW issue.
Here we go. How to use the pi constant in C++. There it is. We're going to need to add this to our boilerplate. # define, use math defines, and include math.pi. So I'm going to go open my boilerplate and make that change right now so I don't ever have to look it up again.
Math.pi. There's a bunch of weird stuff that we don't even know.
Okay, so
I gotta upload the boilerplate.
what we need to do here, yeah, I could upload the boilerplate, is I need to do this, # define, underscore, use, underscore, math, underscore, defines, and then I can include, # include, less than math.h, greater than. All right, now I'm going to save that, but then I'm going to go and add the same lines of code to Visual Studio, all so that I can have the value of pi. What this does is this sets up a flag inside it so that when this file is included, it creates some constants like m_pi.
Let's have some pi.
Okay, so I'm going to do the same thing over here. # define underscore use underscore short-term memory's gone. What is it? Use underscore math underscore defines. Use underscore math underscore defines. And then # include less than math.h greater than.
Yep, sounds like our instructor's brain crashed.
Now I can get the pi out. Get the pi fresh from the oven. Okay, so let's print it out. If you have these two things up at the top, great. If you're not going to bother doing that, I will post the boilerplate so that you can download it. But I'm going to come down here, and I'm going to print out cout less than pi equals less than capital M underscore pi, semicolon. Whoops, no semicolon because I want to go to the next line. Less than EMDL. And there we go, 3.1416. It rounded it to the 4 digits of precision that I asked for.
If you try doing it without the set precision, guess what? It's going to be like 3.1416 by...
Yeah, it'll print it to a lot more precision, but not to the max precision. 3.14159. It prints it out to like 6 digits of accuracy. What if we do this, set precision to 12? We're going to see a lot more decimal places. There we go. I don't know that we needed to be that precise, but we have the option of seeing it now.
3. Oh, looks like I gotta follow the code.
So that's what you use IO manip for. You got to leave that included in there. Let me guess, I didn't leave that in the boilerplate. So over to the boilerplate first. Let me add IO manip there, so it's there. I'll fix that later. Okay, pardon me. What do you need displayed on the screen?
Lecture H. Just go up a little bit. Okay.
Hey, assist, right?
So, working with characters and string objects. Using CIN with greater than causes some problems because it ignores spaces, or it stops with spaces. What do I mean by that? If I come over here, if I come down here, I'm going to delete that hello line, but I'm going to wind up putting something very similar in it. Cout less than, what is your name, question mark, space, greater than, end quote, semicolon. And now we need a string to hold our data, right? So string name and CIN greater than name. And now let's print hello. So cout less than, quote, hello, comma, space, end quote, less than name, less than EMDL. And it's not going to do what we want. It'll work for one word. It'll work like for a first name. My name's Bob. Hello, Bob. Worked great. Run it again and type in a first and a last name. Bob Roberts. Hello, Bob. No, I wanted it to be the whole thing. So the problem is that when you use the greater than, it's doing something called tokenizing. Tokenizing means it splits it up by the spaces. So when I typed in Bob Roberts, the only thing that went into name is Bob. Now I could make another variable to hold the last name, right? String L name, semicolon, and CIN greater than L name. You know, I could do that, but then I don't know in advance whether the person's going to type in one name or two names or three names, you know. John William George Henderson III, right? You know, they may have 5 parts to their name. So that's not a good solution. If the string data has a space or has spaces, you can't use less than. Instead, you have to get the entire line at one time. So you use a function called getLine. So instead of doing this, CIN greater than name, I'm just going to comment that out. And instead, I'm going to do getLine, parentheses, CIN, comma, name, in parentheses, semicolon. What that will do is it'll read in an entire line of data, everything up to hitting the enter key, whether it's 1 word or 10 words.
So we don't have we don't make the strategy.
Pardon me?
We don't make the strategy because string is sometimes string is made the strategy.
Yeah. So it's just getting tokenized up to the point where each piece of data separated by a tab or a space or the enter key gets recorded by greater than, only one piece. But if we want a whole bunch of it, like my name is Bob Roberts 3, by using getLine lets us get all of the data in one piece. So instead, use getLine. Now getLine maybe can cause some problems though. And what do I mean by that? Once you use getLine, it's possible for the rest of it to not work correctly. And what do I mean by that? Let's ask for to do the usual dumb stuff and ask for their age. Pardon me? I'm sorry, I didn't hear you. Cout less than quote age equals question mark end quote, or couple spaces greater than end quote semicolon, and then create a variable called age, int age, semicolon, and then CIN into age. So when I type in my name, Bob Roberts, and then I hit enter, it actually worked. Good. Sometimes these things get a little bit cranky when you start mixing getLine with greater than. We didn't seem to run into that problem this time. So that is goodness. So what if you want just a single character? You don't want a whole string, you just want one character. Well, in that case, we would want to use cin.get. Cin.get, where we pass in the name of a character variable, allows us to read just one character. Well, let's do that at the bottom. Char ch, semicolon, cout less than, press a key, colon, space, greater than, end quote, semicolon. And then CIN greater than, nope, it's CIN dot. Let me make sure I get it right. Let me go look here. Dot get, yep. CIN dot get, parentheses CH, in parentheses semicolon. And then we're going to print back out what they typed in. Cout less than, CH equals space, end quote, less than, CH, less than, ENDL. All right. It is starting to be a little bit wonky now. It said press a key, but before it even let me type in anything, it went to the next line. If I move this code to the top, it might work better. I'm probably just going to wind up commenting it out though. But if I cut all that up and I moved it to the top right underneath main, then when I ran it, it said enter a key, like if I typed in a 7 and hit enter. See, it's still messing it all up. Not really giving us what we want. The stream IO manipulators, when you start mixing them up with .get and with getLine, behave a little bit oddly. Right? We didn't even get a chance to enter our name because they had already entered something by hitting 7 and hitting enter up here. So I don't think that we're going to wind up using .get anymore in this class. So I'm just going to uncomment. I'm going to move it back to where it was down at the bottom, and I'm going to I'm going to comment it out.
Why wasn't it working?
Don't make me explain it. It's because when you're calling the functions .get and getLine, they're not really very compatible with using the IO stream operators. They're trying to read from the input stream in different ways. And I really can't give you a 100% clear explanation because I don't 100% know. I didn't write the language, so I learn workarounds. But I'm never going to just use .get because that's just trying to read the first character of what you typed, and there's other ways of doing that. getLine is very useful, though, if they need to type in more than one word, so we just have to suffer with the fact that it can be unpredictable, and there are ways of fixing that.
Every time you make a syntax error in getLine, it's going to say, oh no, I think you messed up, or something like that.
In fact, that's what the PowerPoint says. Mixing CIN greater than, and CIN.get in the same program can cause input errors that are hard to detect. To skip over unneeded characters that are still in the keyboard buffer, you can use CIN.ignore. So if we really, really, really wanted that to work, we'd have to add something like this after our calls to getLine, or pretty much before every call to greater than. We could put this back there. But then if we're going to ask them for something else, cout less and less, end quote, enter your age again, question mark, space greater than, end quote, semicolon. We're going to have to call CIN.ignore, and we're going to say ignore, I'm just going to enter a huge number, the next 9,999 characters or whatever, or a \n. So single quote or apostrophe \n, end quote, semicolon. And now we could let them type in the age again, CIN greater than age. So after you start using .get or getLine, you may have to start throwing in .ignores if it doesn't seem to be working for you, if it's skipping past your question. We're going to comment this out and see what it does first, and then we're going to add that back in. So with that commented out, does it work correctly? Does it let me type in an age? It may not. What's your name? Jeff. Age, 12. Press a key, CH equals, enter your age again. Well, see, it's behaving oddly. What if I uncommented that .ignore? They can behave a little bit better. What's your name? Jeff. Age equals 12. Press a key. What's your age again? See, it keeps skipping past this one. .get is a real pain to try to get to work perfectly. Maybe if I move this and make a copy and paste it there. Yep, now it's finally starting to work.
Where did you copy paste it?
I'll show you. I put a copy of it. Actually, all it needed to be is right above CIN.getCH. And you only need to do that if you start mixing .get with .getLine and greater than greater than. If you're just going to use greater than throughout like we've been doing, then you can totally do away with this idea. What this number is how many characters it might have to ignore before it finds the \n. Now realistically, is it really going to need to ignore that many? No, we could probably get away with just making it 1 or whatever, but you may as well make it a huge number. It just doesn't matter. It doesn't change it the way it works.
So what happens if our whole pi equals
I'm sorry, I didn't understand the question.
they quit popping up on mine?
Which part didn't?
The pi function?
I need to go ahead and type in the H whatever thing.
Well, a whole bunch of stuff. It's underlined.
Well, let me do this.
Oh, that's cool.
I know.
And let me put it down so I can build reveal solution. Character represented by a universal character cannot be represented.
Okay, I learned a little bit better, but it still sucks.
What do you get
That's
line?
too bad.
Yeah.
But that's cool. It means it's not saved in Unicode.
I'm not going to use getLine again.
It doesn't seem like it's really worth the effort.
I'd rather just be lazy, just find an easier way to do it,
Yeah.
right? Well, we're almost done.
I was trying to get it a group on.
Sure.
I got 15 minutes. Right? Yeah. Any space in there?
We could build that, it's not gonna stop it. Yeah.
Is there any way we can get it to get the Unicode character?
Well, I don't know how to save a C file as Unicode,
It's just out.
but we could print out that value, that letter, if we knew what it was in ASCII. Let's take a look. Is there a pi character if we go to ASCIItable.com and we look at the extended characters? Is one of them the pi symbol?
There's no pi.
I'm not spotting it, which is surprising because they have things like square root and plus minus and other things.
There you go.
Including not equals.
Ah well, let's go on. So, if your program is behaving oddly and it's skipping past an input question, you're going to have to put cin.ignore in front of it to read in any stray characters that are left in the input buffer. So if you need to find the length of a string, you can call state.length. In Python, if you wanted the length of a string, you'd do this. You'd do len parentheses state, and that would tell you the length of it. But in this language, state.length will give you the strength. The length. Then if you want to add two strings together, that's called concatenation, and you just use a plus sign. So let's go back to our code, and we already have a name that we had them enter, right? So name plus equals, quote, is awesome, exclamation mark. And then let's write that out. Cout less than name less than endl.
My local Windows debugger is on.
Nope, it didn't work.
Something's going on with that cin.ignore. It made me hit enter twice or something like that in order to work. So again, I'm going to start commenting out this stuff to get it to stop malfunctioning. I'm going to get rid of all of this. Yes, sir.
My local Windows debugger button's gone.
Weird.
Ouch.
All right, so it's working. Usually when that happens, it's meaning that we opened up a CPP file, and that just means that it's currently running. Yeah. If you don't see the run button, or it's grayed out or something like that, there's two possibilities. One is that it's running already in the background, right? I just went back here. I can't run it now because it's already running and you have to find and kill it. The other problem is if you open a CPP file without a project, right? If I go and I find some other CPP file I wrote in the distant past, there won't be a green button that says local Windows debugger. It'll say something like attach process or something like that. And what it means is I'm just editing a CPP, but I'm not in a project. And in that case, you have to make a project, and then you can put this file into it, and you can get it to go. So, string, first name equals quote Sue, end quote, semicolon. String last name equals quote Williams, end quote. And then so name equals first name plus double quote space double quote plus last name, semicolon. And then C out name now equals space end quote less than name less than ENDL. So what's your name? Joe Bob. Age is 12. Age is still 12. Joe Bob is awesome. Name now equals Sue Williams. Now, unfortunately, we've learned a lot of interesting stuff, but nothing that would make for a good homework assignment here, right? So we need to take a step back because we're pretty much at the end of the chapter and figure out what we're going to do next. Oh, math library functions. That'd be worth talking about. Maybe we can get some homework out of the math library. So if we # include CMath, then we have functions like sine, cosine, tangent, square root, log, absolute value. How about arctan? Could we convert rise over run into an angle? So arctangent, CMath, C++. And this isn't a geometry class, so we're not going to spend too much time trying to figure this out. But atan, what arctangent does is if you have a triangle, a right triangle, you know what a right triangle is? It's one with 90-degree angle on it, like this. It's got a rise, and it's got a run. And if you wanted to figure out that angle, then you divide the rise over the run, and then you take the atangent, the arctangent of it. Do that, divided by that, click atangent, and it gives you the angle. But it gives you the angle in radians, which you would then have to convert into degrees. Now this is way too, junior high mathy for my taste. I don't want to know what radians are. But you just need to know that these functions, like arctangent, are going to give you values in radians, which you then need to convert into degrees. So, if we have like 1 over 1, that should be a 45-degree angle. So let's see if we can use the atan function to get 45 degrees by calling some of these functions. So we're going to come over here and let's just set double rise equals 1, double run equals 1, and then our ratio, which is our slope, double slope equals rise dash run. And now let's get our angle. We've already # included CMath, so we don't have to sweat that. Double space angle equals ATAN parentheses slope in parentheses semicolon. Now I saw several different versions of ATAN coming up. I wonder if one of them actually returns. Nah, nothing looking good there. And then let's print out the angle. So C out less than quote angle equals space end quote less than angle less than ENDL. Okay. And it says that the angle is 0.7853. Well, that's because it's in radians. We don't want it to be in radians. We need to figure out how to convert from radians to degrees. And I bet one of your math major types would know how to do that off the top of your head. Convert.
I know how to do it.
How do you do it?
So basically, you do pi divided by 180 for whatever radians you got. If you
Oh,
got
so it's 180 divided by pi, huh?
Yeah.
Okay, cool. So let's do that.
Okay.
Let's do angle equals angle. I've already forgotten.
180 divided
Times
by
180 divided by pi
pi. Yeah.
times 180 divided by, and we figured out how to do pi earlier. What was it? It's m underscore pi. Awesome that you know that. Okay, there we go. There we go. So now we have convert radians to degrees. Just because we like degrees. We like knowing 90 and, you know, and 45 and stuff like that. That's how we learn. Now it should be 45. Oh, I have to answer all these stupid questions. Okay, and that worked. So this is an example of calculating the angle of a right triangle based on its rise and its run. So your homework is going to be a little bit similar. I mean, it's going to include part of that. If I could type a double slash, that'd be dangerous. Here we go. Homework. Write a program that asks the user to enter the rise and the run, which is the height and the width, of a right triangle. Use that information to calculate the angle, the length of the hypotenuse, and the area of the triangle. So we need to know how to calculate the length of the hypotenuse. Have we already done homework where we did hypotenuse?
No.
Okay, so hypotenuse, what is that? That's Pythagorean theorem. Yep.
A squared plus b squared equals c squared. If you want, we could do a physics problem. E equals mc.
There, like this. A squared plus b squared equals c squared. The c squared is the long one, and a is the rise, and b is the run. So we're going to have to calculate how to get c. So yeah, we just need the square root. So all we got to do to get this to work, to calculate that value, is we're going to need to add a squared plus b squared, or rise squared plus run squared, and then we're going to need to take the square root of that. And we have a function for that. SQRT. So let's write some formulas down into our homework assignment. Hypotenuse is equal to SQRT, parentheses, rise times rise plus run times run. And the hypotenuse is just the long measurement, the angle, the diagonal. And then the area is even way simpler than that. It's just rise times run divided by 2.
Or you would have had to use POW, whatever.
We could use POW. If you like POW better, that'd be pretty awesome, right? POW, rise, comma 2. You feel like doing that? That's cool. All right.
Rise times rise plus run times run.
Yeah.
I do not like C++ due to the fact that they do not have an exponential.
The code above shows how to convert rise and run to an angle. Or, I mean, should I rewrite it into the homework? We've already got it up here, but
Okay. Will these directions be on the Dropbox?
of course, yeah, absolutely. You do
So
not
I
have
don't
to type all
copy that
this.
down.
Right, okay.
I better make sure there's no syntax
Yes,
errors. What?
I just want to see that animation. Okay. You know how to see waves?
All right, there. All the formulas are right there to make it easy. Calculating angle, it's just A tan rise / run times 180. And the hypotenuse is that, and the area is that. So to test it with rise and run both set to 10. The angle should be 45. The area should be 50. And I don't know what the rise over run is. The hypotenuse be the square root of 200. About 14.14. If you test it with rise and run set to 10. Okay. So I hope that makes sense. That shouldn't be too bad of an assignment, actually.
Can you go over to the
Yeah, to which point?
concatenation?
Right here?
Concatenate.
Oh. Right there?
Yeah.
Yeah, sure. Let me make the Dropbox and we'll go back to that because we're about done for the day. Yes, sir.
I got a function underscore pi is undefined or whatever.
Okay, I'll be right over there.
I think they have different chairs in here.